Your properties of acids and bases. We're going to look at the actual properties of them themselves. You guys actually already saw all of these things, but just to make sure that you know the basics of your acids and your bases, we are going to just kind of make sure that everything is highlighted for your vocabulary aspect of it. So the first thing that we're going to look at is your acids. And as we figured out through eating the sour candy, that acids taste sour. So a lemon is sour because of its acidic properties. I don't know, a sour orange, same thing. If you've ever tasted vinegar, it's real sour. That's because all of these are acids. So acids taste sour. Typically you don't eat anything in a lab, but if anything has a sour taste, it's because it's acidic. They all conduct electricity. So they're all ionic compounds, so you have ions that are floating around in the solution. They go through dissociation. They're going to conduct electricity because they have positive charges and negative charges. They turn litmus paper red, and I've got a slide with a better picture of litmus paper again here in a second, but acids are red. They all start with hydrogen ions. That means that they have hydrogen ions present. The definition of an acid is something that has hydrogen ions there. So they're all going to have hydrogen ions. They're all going to be written in the first spot. They all have a pH less than 7. So anything that is 6.9999999, not 7, but all the way up to 7, you have, and below, is going to be an acid. So the lowest part of the scale for our classes is 0. It goes up to 6.9 forever. All of those are going to be in the acid range. The closer you get to 7, the weaker it is. The further away from 7, the stronger it is. So the word, well, it's not, there we go, sorry. The word that we were just talking about with your litmus paper, it is this stuff. I'm trying to figure out where to move myself. It is this stuff right here. There's red litmus paper and there's blue litmus paper. But litmus paper is coated with a lichen, which you guys talked about in biology last year. And the lichen changes color either from red to blue or blue to red, or sometimes they stay the same, to indicate if you have an acid or a base. So if you have an acid, your red litmus paper is going to stay red. Blue litmus paper is going to change to red. Now it says red, I know it's really pink, but it's called red and blue litmus paper. So acids are red. You're going to find out in here in a minute. Bases are blue. So this is a base, this is an acid. Now, if both of the papers turn, so the red turns to blue, the blue turn, then you know that you have a different situation there. But this is actually a base, this is an acid. So some real life acids that you have in the real world. Lactic acid is what you find in yogurt. It's found in milk, things like that. Citric acid is what makes an orange or a lemon or a lime. Give it all the acidic property. And then carbonic acid and phosphoric acid you find in soda. That's why it's not so good for your teeth. So these are just some real life acids that you'll find. Acetic acid is vinegar. You have a lot of examples of these. You just don't realize that there's quite as many acids and bases in the world around you. Now bases are next. Bases taste bitter. So you had that chocolate that I had you guys taste, and it was very bitter. Coffee is another one that's very bitter. So a lot of times we can't really figure out what is a bitter taste, and that's because we don't eat a lot of bitter foods. But bases taste bitter. Bases, bitter. They feel slippery, like soap is a good example of a base. So they kind of have that like slimy feeling. That's a property of a base. Bases are blue in litmus paper. Taste bitter. They're blue. B's altogether. They also conduct electricity because you have ionic compounds present. And then you have a pH that is bigger than 7. If you're exactly 7, it's actually neutral. So anything bigger than a 7, it is a base. So 7.000001 is a base. Exactly 7 is neutral. So some real life bases, these are typically cleaners. We don't usually eat bases because they would neutralize our stomach acid, which would cause other issues. But your bases, you have bleach, you have ammonia, you have soaps, all of those are cleaners. Antacid, it's there to neutralize out your stomach acid, so that is a base as well. When we think about that bitter taste, if you were ever the not so good kid and you were telling your parents dirty words and they put the soap in your mouth, either the bar of soap or if your parent was really mean, the liquid soap, that taste that you will never forget, I will never forget that taste. It's bitter because soap is a base. So looking at your pH scale, again, if you have a pH of 7, that's neutral. Bases are bigger than 7, so you have 8 all the way up to 14. So some other examples, we've got eggs, we've got baking soda, toothpaste, milk of magnesia, ammonia, soapy water, oven cleaner, bleach, liquid drain cleaner, all of those things, this is lye, caustic soda, all of those are bases. This scale down here is for your acids. So you have urine, you have milk, you have acid rain, black coffee, tomato juice, grapefruit juice, lemon juice, vinegar, battery acid, hydrochloric acid that's in your stomach. All of those things are all considered to be acids. The further you get away from 7, they get stronger and stronger and stronger. So these are the strongest acids. Same thing up here, you can have really strong bases that you get stronger and stronger and stronger. Now the tricky thing about acids and bases is by looking at them, you typically cannot tell if it's an acid or a base. You have to do a test because most of them are clear liquids. So they mainly look the same. They all look like water. So unless you taste them or you feel them or you do a pH test or something like that, you're not really sure what they are in terms of their strength or anything like that. So what you have to do is you have to use something called an indicator. And an indicator is something that changes color to tell you if you have an acid or a base, and some of them are pH specific. So we have pH paper that we used in the lab, and that pH paper told you the pH of the compound or the substance. You have something like universal indicator that goes through a whole rainbow of colors here. That is a specific indicator that'll tell you based off of the color what pH you have. So as we look at the different indicators, they will help you to figure out if you have an acid or a base. Now, I'm sorry, it kind of snuck up on me. Allergies are horrible today. Hydrangeas, there's actually a lot of natural indicators. We're going to use one that is made out of cabbage, but hydrangeas are a natural indicator as well. Based off of the pH of the soil, they'll change to either blue or pink, depending on if you have acidic soil or if you have basic soil. So looking at your acids and your bases, it is a natural indicator. Sometimes like coffee will change, or not coffee, tea will change colors if you have like lemon added to it or anything like that. And that's because it's actually changing because of the pH difference. So we will look at a lot of different indicators as we go through this unit. Otherwise, I hope that this clarified anything that you had questions about.